So this video is going to continue chapter 12 of geometry. It's going to cover 12.6 to 12.7, and by the end of this video you should know about proportional area and proportional volume, as well as two more conjectures about proportionality. So the proportional area conjecture says that if two similar polygons or circles have lengths of corresponding sides or radii in the ratio of m to n, then their areas are in the ratio m squared over n squared. So essentially, if we have, say we have a triangle here and a triangle here, and the sides of this triangle are 2, and the sides of this triangle are 6. So we know that the factor is 3, so it's a ratio of 1 to 3. Then their areas are going to be in the ratio 1 squared over 3 squared, or 1 to 9. So if we were to find the areas of these triangles, their ratios would end up being 1 to 9. That doesn't mean that the area of this triangle is going to be 1, or that the area of this triangle is going to be 9. It could be 3 and 27, or 4 and 36, but it's going to be in this ratio. So this is very similar. The proportional volume conjecture says that if two similar polygons or circles have lengths of corresponding sides or radii in the ratio of m to n, then their volumes are in the ratio m cubed over n cubed. So this is the same thing as before. Say we have, for example, a cube, and it has sides of length 2, and then we have a bigger cube that has sides of length 6. Then again, this multiplier is going to be 3. It's a ratio of 1 to 3. Then the ratio of their volumes is going to be 1 cubed over 3 cubed, or 1 to 27. So if we're given two figures, for example, if we're given two triangles, and we're told that the area of this triangle is going to be 5 centimeters squared, and the side of this is 2, and this side is going to be 5, and then we're asked to find what is the area of this triangle, and we're told that the triangles are similar. So we know that the ratio of the sides is going to be 2 to 5. So we know that the ratio of the volume, or of the areas, excuse me, is going to be 2 squared over 5 squared. So that turns out to be 4 over 25. And if we know that the area of this one is going to be 5, and we need to find the area of this one, we can set up a proportion. So 4 over 25, since this is the smaller one, it's going to go with 4, and then over x for the area of this one. We're going to cross multiply, so we're going to get 4x equals 125, and we can divide that out, and that turns out to be 31.25 centimeters squared. So this first conjecture here, the parallel proportionality conjecture, says that if a line parallel to one side of a triangle passes through the other two sides, then it divides the other two sides proportionally. And conversely, if a line cuts two sides of a triangle proportionally, then it's parallel to the third side. So if we have our triangle, and we have this line at the bottom, and then we have a line going through it here that's parallel, then this is going to be proportional to, or the ratio of this to this side to this side, is going to be proportional to the ratio of this side to this side. And then our extended parallel proportionality conjecture says that if two or more lines pass through the two sides of a triangle parallel to the third side, then they divide the two sides proportionally. So if we have another line, so we have our first line here, and if we have another one here, then these are still going to be proportional. And this doesn't depend on the size, shape, or size of the triangle. If we have one like this, it's the same, it's still going to be proportional.